Okay, so the problem is asking us which of the following functions has the complex number 1 plus square root of negative 1I as a solution. And we know that 1 plus the square root of negative 1 is equal to 1 plus I. So if x, this has to equal x, and then when we input this into the following functions, the value should equal 0. So if we try for each of the functions, we can see each of the functions have x squared being inputted. So it would help us if we were to just square this initially, because we're going to need it for whichever function is our answer. And 1 plus I squared is equal to 1 squared plus 2I plus I squared, and I squared is negative 1, which means this thing equals 2I. So we know x squared is equal to 2I. So we know it has to equal 0. So if x squared equals 2I, we need to get rid of the 2I, which means x squared plus 1 is not a solution, because it's just equal to 2I plus 1, which is not equal to 0. And for these other four functions, we can, since it's the ACT, we're allowed a graphing calculator. So if you want, you can graph each of these. They should all fit within a negative 10 to 10 and negative 10 to 10 XY window. So if you were to graph all of these in your graphing calculator, you'd actually see the function, this function right here, has two real zeros. And as you can see, this is 1 plus I, which is not a real number, which means that this is also not a solution, because solutions come in pairs. So we know that F and J are out. Now for the other, the other three, we could just use simple substitution, substituting 1 plus I into each of these three equations. And by doing so, we can see which one of these equals 0. So we already know, since we did it in the very beginning, that 1 plus I squared equals 2I. And we know x equals 1 plus I right here. That's the x value we're trying to input. So let's try with it with g. It says x squared, so we already know that equals 2I, plus x, and remember, this here is our x, so, and that's equal to 1 plus I, so plus 1 plus I plus 1 right here. X squared is this, plus x is this 1 plus I plus 1 right here. And this is supposed to equal 0, but as you can see, it equals 3I plus 2, which is not equal to 0, so we know it's not this. Now, for the next equation, x squared minus x plus 1, we can substitute again. We know x squared is equal to 2I right here, x squared 2I, minus x, which means minus 1 plus I, remember in parentheses, you don't want to make any silly mistakes, plus 1, and what is this equal to? Well, this is equal to 2I minus 1 minus I plus 1. And what is this equal to? Well, the two ones will cancel, minus 1 plus 1, and 2I minus I is equal to I, which is not equal to 0. So, you can probably already tell it's the last problem, but you should always work it out just to be sure. But it's number 60, so if you are rushing, you can safely conclude it's K. But let's work it out anyway, just to make sure. So we know the equation is x squared minus 2x plus 1, so we can make the same substitutions we've been making. We know x squared is equal to 2I, so x squared 2I minus 2 times x, and I think you might already see what's about to happen. You'll multiply this 2 by this I, and then you'll see that that'll cancel out with the initial 2I you got from x squared. So this simplifies down to 2I, distribute the negative 2, and you get minus 2 minus 2I plus 2. And what is this equal to? Well, the minus 2 cancels out with the plus 2. 2I cancels out with minus 2I, and that leaves you with 0, meaning the answer to this problem is K. Now, another way of approaching this, like I said, you could use your graphic calculator from the very beginning, just to see which functions go through the x-axis, and that would help you get rid of j immediately. Another way would also be using the quadratic formula for each of these problems. However, I think this is the quickest way to do this problem because you already know your x, 1 plus I, and if you square it, you can simplify it to 2i, and then all you need to do is make a few substitutions and distribute, and that's probably the best way to do this problem.